All right, let's first take a look at how to switch from log form to exponential form. Okay, the video is working. Yes. All right, so exponential form, you can see how I color-coded it. So the base is the tiny number next to the word log. So whatever you're raising the base to, that's your exponent, and then your result is your answer. So down here, we're going to take what's written in exponential form and write it in log form. So first thing that I'm going to do is I am going to look and identify the base. So the base in part A would be 3, in B it's 2, in C it's 10, in D it's 8, and in E, I don't know what it is yet, I can't see it. But the base is 36. So I identify the base. Now what follows the word log is what your answer was. So for part A, my answer is 27. So log base 3 of 27. And then in B, log base 2 of 1/8. C, log base 10 of 1/100th. Notice how I read the decimal correctly. That's what you want to do whenever you encounter a decimal. D is log base 8 of 1. And so a logarithm is an exponent. So it's equal to the exponent. So my exponent was 3. In B, it was -3. In C, it was -2. In D, it was 0. And in E, it was 3/2. So that's just how you switch from one form to the other. So it's log base 3 of 27 is 3. So you're just switching forms. A logarithm is always equal to the exponent. On the right-hand side, what we want to do is write each log equation as an exponential equation. So we're going in the other direction. So I'm going to speed it up a little bit. So what I'm going to do is identify the base, and I usually like to draw these arrows. So 4 to the third power equals 64. Next up, 9 to the 3/2 power equals 27. 5 to the second power equals 25. On part D, 6 to the 0 power equals 1. And E, 3 to the -2nd power equals 1/9. So what's nice about this is it reviews a lot of aspects of Algebra 2. For example, in part B, rational exponents comes up, and then also negative exponents. So because logarithms are exponents, it reviews all those exponent properties, which is fantastic. Now down below, now there's 3 different locations that you could be solving for. You could be solving for the base, you could be solving for the exponent, or you could be solving for the number. So these 3 problems here kind of detail those 3 different scenarios. For example, in number 1, first thing I do is I switch to exponential form. So 2 to the y power equals 64. And then what I did is a technique called matching my bases. We'll see this a lot. 64 is the same thing as 2 to the 6th power. And if your bases are equal, your exponents are equal. So y would have to be 6. In 2, I switch forms. So 9 to the 1/2 power equals x. And that variable is all by itself. So I just need to evaluate this. Here's some Algebra 2 review. When you have a fractional exponent, the top number is the power, the bottom number is the root. So you take the square root of 9 and then raise it to the first power. So you end up with 3. The final one in number 3, I switch it to exponential form, and I have b squared equals 16. And then I use reciprocal exponents, so raise both sides to the reciprocal power. And that's how I find out what my variable b is.